Today we'll be going through Cambridge AS A-Level Mathematics Paper 1, Pure Mathematics 1, 970912, May-June 2020. Question number 1. A part, find the coefficient of x square in the expansion of this. So expansion, we know that expansion of a plus b raised to power n can be written as like for example, if we require x square, basically we require, so we can write it as ta plus 1 will be equal to nca and a raised to the power n minus a b raised to the power a. Now as we require x square, so for x square we will take a is equal to 2, so our equation will be 2 plus 1 is equal to 6c2 and x raised to the power 6 minus 2 and into my a value is 2 minus 2 over x, so minus 2 over x raised to the power basically a, which is 2 in this case. So this will be, we can simplify this one, 6c2 will be equal to 15, so this will be 15 x raised to the power 4 and into square will be 4 over x square. So after cancellation we will get 15 fours are 60 x squared. This will be our final answer to this question. B part, find the coefficient of x square in the expansion of this one. So there will be two parts of this expansion. One will be the a part, which is this one which we already found, and there will be another thing which will be term which is not involving x. So term without x, we can write that term, that will be basically a3 will be having a, for that one a will be equal to 3, so we can write t3 plus 1 will be equal to 6c3 and x raised to the power 3, we are expanding only this portion, so x raised to the power 3 and minus 2 over x raised to the power 3, so these two will be cancelled and remaining this one we know is equal to 6c3 is equal to 20, so this portion is 20 and this will be cancelled with this cube, and minus 2 cube will be basically minus 2 cube will be 8, so this will be equal to 160. So this will be cubed and it will be 160. Hopefully you got this. Basically this will be minus 8 and it will be minus 160. Now one portion is this one and the second portion will be this one in expansion of these two. So we can write 2 plus 3x squared, 2 plus 3x squared as it is, and x minus 2 over x whole raised to power 6. So we will be just writing this one as it is, 3x squared, and expansion of this one, we need only the x square part, so it will be 60x square, and this one we found in part A, and the remaining is minus 160. So this will be the value from part A which we have inserted, and now we can multiply this one. So 2 into 60 will be 120 x squared, and 3 into this one will be minus 480 x squared, and we will leave the other terms. So we write leaving the other terms. So we have taken only x square, and if we subtract this one, this will be minus 360 x squared. So coefficient of x square will be minus 360, and this will be our final answer. Question number 2. A part, express the equation, this one, as a quadratic equation in sine x. So we can change this tan x. We know tan theta is equal to sine theta over cos theta. So this is the value which we'll be replacing in this one. So we'll get 3 cos theta is equal to 8 sine theta over cos theta. And now we can cross multiply. So cross multiplication, this will be 3 cos square theta is equal to 8 sine theta, and cos square theta, we know cos square theta is equal to 1 minus sine square theta. So this formula we will be replacing this cos square theta. So 3 into 1 minus sine square theta will be equal to 8 cos theta, 8 sine theta. So it should be sine theta over here. Now this one we can open bracket and it will be 3 minus 3 sine square theta is equal to 8 sine theta. We can shift these to the other side, so our quadratic equation will be 3 sine square theta plus 8 sine theta is minus 3 is equal to 0. So this will be the quadratic equation. So in this part they are looking for quadratic equation. So we are done. Part B, hence find the acute angle in degrees for which this is equal to this. So the same quadratic equation which we found in part A, that we can solve. So it will be 3 sine square theta plus 8 sine theta minus 3 is equal to 0. Now we can take the coefficients, basically mod 5 3. So coefficient of sine square theta is 3 and sine theta is 8 and constant value is minus 3. So it will be 1 by 3 for x1 and minus 3. Now we can change the sign. So this will be minus, this will be plus, and we can write it as x, 3x. For this one it will be 3x minus 1, and for this one it will be x, x plus 3. So in this case, because x is sine theta, so we will write 3 sine theta plus minus 1 and into 3 sine theta plus 3. So this is the working which we have done. So this will be equal to 0, and now we can find from here 3 sine theta minus 1 is equal to 0, or it can be sine theta is equal to sine theta plus 3 is equal to 0. So sine theta is equal to 1 by 3, and here sine theta is equal to minus 3. So if we calculate basically mod 1, so theta sine inverse of 1 over 3, and this will give us answer as 19.471. So we can write here theta is equal to sine inverse of 1 over 3, which is equal to 19.47 degrees. And if we check for the other one, which is sine inverse of minus 3, and this will be basically math error, so we will ignore this one. So this is our final answer. Hopefully you understood this. Question number 3. A weather balloon in the shape of sphere is being inflated by pump. The volume of the balloon is increasing at a constant rate of 600 centimeter cube per second. The balloon was empty at the start of pumping. So find the radius of balloon after 30 seconds. So for this one, change in volume dV over dt is provided, which is 600 centimeter cube per second. So this is basically the information provided over here. And then at t is equal to 0, at t is equal to 0, volume is equal to 600 centimeter cube. And at t is equal to 30 seconds, so we can write 0 seconds. So volume is basically 30 multiplied by 60. So it will be 30 multiplied by 600, not 60. So this will be 18,000 centimeter cube. And volume, we know volume of sphere is equal to 4 by 3 pi r cubed. So this is the formula which we will be using. So this volume at 30 degrees Celsius, 18,000 is equal to 4 by 3 pi r cubed. Now r cubed, we can check r cubed. This implies r cubed is equal to, we can shift this, so this will be 3 into 18,000 divided by 4 pi. And this implies r will be equal to cube root of 3 into 18,000 divided by 4 pi. And we can simplify this one. This will be cube root of 3 into 18,000 divided by 4 pi, and this will be resulting to 16.25. 16.2577821. This is basically the calculated digits, so approximately equal to 16.3 centimeters. This will be the radius of this one, radius of the balloon after 30 seconds. Now B part, find the rate of increase of the radius after 30 seconds. So what will be the rate after 30 seconds? We know volume is equal to, basically volume is equal to 4 by 3 pi r cubed. This is the formula, and we can find the dV over dr, basically change of volume with respect to radius. So constant as it is, and this one will be 3r squared, derivative of this one, and this one we can cancel 3, so it will be 4 pi r squared will be the dV over dr. Now we can find dr over dt, and dr over dt is equal to what? dr over dv into dv over dt, and dv over dt, change in volume with respect to time, is basically 600, which this is given. So we will use this information in this one, and this will be, we found this dv over dr, but we need dr over dv, so we'll take reciprocal of this, so it will be 4 by pi 1 over 4 pi r squared into dv over dt, which is 600, and we can calculate this value, and this value basically which have r value we have calculated over here. I will use this whole value calculator number, so I will write 1 over 4 pi and answer square, so it will be 1 over 4 pi and answer squared, this one, and multiply by 600. Hopefully you are understanding the calculation. So it will be 0.1806. So this is equal to 0.1806, and approximately this will be equal to 0.181 centimeters per second. This will change. Now this is question number 4. The nth term of an arithmetic progression is this one. Find the value of n, which the sum of the first n terms, for which the sum of the first n terms is 84. So what we can do, we can use this given formula, nth term, and for n is equal to basically 1, n is equal to 1, we can write this formula. So t will be equal to what? T will be equal to 1 by 2 into 3 into 1 minus 15, and this will be 3 minus 15 will be 12, 12 divided by 2 will be 6, so basically this will be minus 6, and this is basically for n is equal to 1, so this is value of a, so a is equal to minus 6, this is basically the value of a. Now for n is equal to 2, we can write the same thing as t2, with this is equal to 1 by 2 into 3 into 2 minus, again this will be 15, and this one will be equal to 3 into 2 will be 6, so 6 minus, this will be minus 9, minus 9 divided by 2 will be minus 4.5, so this will be the second value. Value of d we can find, basically this will be t1, t2, so we can write t2 minus t1, which is equal to minus 4.5 and minus 6, so this will be equal to 1.5, so this will be our d value. Now we have d value, we have a value, so we can apply the formula Sn is equal to n by 2 into 2a plus n minus 1 into d, and Sn we know is provided 84, so we can write here 84 is equal to n by 2, and we have to find, and 2 into a value is minus 6, and plus n minus 1 into d value is 1.5, and this is done, but basically we have to shift this 2 to this side. It will be 168 is equal to n into, this will be minus 12, and this one will be plus 1.5n and minus 1.5, so we can put bracket over here. Now we can simplify these two, and basically we can multiply, so n into minus 12 plus 1.5, so minus 12 plus 1.5 will be resulting to minus 10.5, so it will be n into minus 10, otherwise we can write this one first, 1.5 n and minus 10.5, and this will be 168, and we can write this one 168 is equal to 15, it's not 15, 1.5 n squared and minus 10.5 n, and we can shift this to other side, so 1.5 n squared minus 10.5 n minus 168 is equal to 0. Now this is basically the quadratic equation which we can solve, and for that one we will be using mode 5(3), and this one will be 1.5 coefficient of n squared and minus 10.5, and next is minus 168, and this will be equal to 14.5, and this one will be minus 7.6, so we can apply quadratic formula for that one. Basically we have done mistake over here, this is minus 12 and minus 1.5, so it will be minus 13.5, so this will also be minus 13.5, and this will also be minus 13. So after this rectification, if we apply this quadratic formula, so it will be 1.5 coefficient of n square and minus 13.5 and minus 168, so our answer will be 16 and minus 7, so we can write n is equal to minus 7 and n is equal to 16. If you want, you can write the quadratic formula, like for example x is equal to, basically n is equal to minus b minus 13.5 minus b plus minus b square, which is minus 13.5 squared minus 4 into 1.5 into A and C, C will be minus 168 over 2A, so divided by 2 into 1.5. So you can add this step if you want, and after that this will be basically this will be the answer 16. This one will be answer. Hopefully you got this. Question number 5. The function f is defined for x belong to R by this detail is given, where a is a constant, express f of x and f inverse of x in terms of a and x. So f of x, we can write f of x is equal to a minus 2x, and f of x, we can replace this x by a minus 2x, so it will be a minus 2 into a minus 2x. So this one, now we can open the bracket and it will be equal to a minus 2a plus 2. 2 into 2 will be 4, so it will be 4x. So after simplification it will be 4x minus a, and this will be basically f of x value. And now to find the basically f inverse of x, what we will be doing, we will be writing like f of x we can write equal to y, and y is equal to a minus 2x. Now we can make x a subject, so this will be x will be equal to we can shift, so it will be y minus a and divided by minus 2, and now we can accommodate this minus, so it will be a minus y over 2, and we can swap x and y, so y is equal to a minus x over 2. This will be basically the f dash of f inverse of x, basically f inverse of x. This will be our answer. Then B part, given that f of x is equal to f inverse of x, and this is basically f of x, so 4x minus a is equal to we can write this one, which is a minus x over 2, and we can cross multiply, so it will be 8x minus 2a is equal to a minus x. Then we have to just simplify, shift this to the side, so 9x is equal to 2a plus a, which is equal to 3a, so x is equal to 3a over 9, which is equal to a over 3. So this will be our answer, x is equal to 1 by 3a. This will be our final answer. Hopefully you understood this. Question number 6. The equation of the curve is this one, where k is constant. Given that the line this is a tangent to the curve, find the value of x. So curve and line, tangent to the line, line is this one is the tangent to the curve. So tangent and curve are having one point common, so for that point we can basically equalize both equations to get the point. So we can write this one, 2x square plus kx plus k minus 1 is equal to 2x plus 3, and now we can solve this one. So 2x square plus kx and minus 2x we can shift to this side, and plus k minus into minus 3, basically minus 1 and minus 3 we can write here, minus 1, and this will be minus 3 is equal to 0, and if we simplify, this will be kx square, and x we can take common, so it will be k minus 2 and x, and this will be plus k minus 4, so k minus 4 we can put in brackets. So this is basically the quadratic equation in terms of x. So we can check the discriminant. So we can take b square minus 4ac is equal to 0 because it will be repeated root. So we will be taking b value is basically this one, k minus 2 squared minus 4 into a will be 2 and c will be k minus 4 is equal to 0. And now we can just open this. This will be k squared and plus 4 and minus 4k, and this will be minus 8k and this into this will be plus. So this will be plus 8 into 4 will be 32 is equal to 0. Now we can write this basically k squared and minus 12k and plus 36 is equal to 0. Now if we solve this one, so coefficient of k square is 1, then minus 12 and 36 is, and so it will be 6 and 6 basically. So this is 36 is equal to 0, so k value will be equal to 6. This will be our final answer. It is now given that k is equal to 2. So k is equal to 2 is given. Express the equation of the curve in the form y is equal to this one, where a and b are constants, and hence state the coordinates of the vertex of the curve. Now for b part, what we will be doing, we will be writing the quadratic equation which is provided in this one, and k is equal to 2 will be replacing there. So it will be 2x squared plus 2kx, kx we will write 2x and plus k, which is 2 and minus 1, and this will be our quadratic equation. And we can basically take common 2 from these two, so it will be 2 into this one, we can write x squared plus x, and this will be plus 1. So this format, and now we will be completing square method basically. This one we can write x plus whatever here, which is 1, so divided by 2, and this will be whole square, and minus whatever here, which is 1 by 2, so square, and plus 1, this one. So now what we can do, we can multiply this 2 inside, so it will be 2 into x plus 1 by 2 squared, and minus 2 into 1 by 4 and plus 1, so this will be 2 into x plus 1 by 2 whole squared, and minus this will be 1 by 2 plus 1, so the final equation will be 2 into x plus 1 by 2 whole square plus 1 by 2. So if we compare this equation and this equation, a value is 1 by 2, a is equal to 1 by 2, and b value is also basically 1 over 2. Now they are saying hence state the coordinates of the vertex. So for coordinates of vertex, we know x value is equal to minus b over 2a. So minus b will be minus 2a, not 2a, 2 over 2a will be, so this is also basically 2 into 2, so this will be equal to minus 1 by 2. This is basically x coordinate of the vertex. Now this one we will replace in quadratic equation, even directly we can replace here. So minus 1 by 2, this factor will be 0. So if this is 0, this will be equal to 1 by 2. So y will be equal to 1 by 2. We can write the point which minus 1 by 2 and 1 by 2. Hopefully you understood this. This is done. Now question number 7. Question number 7 says diagram is provided. In the diagram OAB is a sector of circle with center O and radius 2r. The angle AOB is equal to 1 by 6 pi radians. The point C is midpoint of OA. Show that the exact length of BC is r under root 5 minus 2 root 3. So to show this one, we will consider this triangle OBC. So in OBC, we have to find BC. So BC squared is equal to OC squared plus OB squared minus cosine rule, basically we are applying, minus 2 into OC into OB cos of pi by 6, basically this one pi by 6. So this one we can write OC is basically r, so r squared plus 2r whole squared and minus 2 into r into OB, which is 2r, and cos of pi by 6 we can check for that one. Cos of pi by 6 will be cos of pi over 6, which is equal to under root 3 by 2. So we can write here under root 3 by 2. This 2 will be cancelled with this one, so we will get 4r squared plus r squared, so 5r squared minus this will be 2r squared, so under root 3, so under root 3, this one. So now what we can do, we can this is basically BC square, so BC will be equal to BC square will be equal to r square, we can take common, so r square into 5 minus 2 under root 3, this one. So now we can take root for BC value. This will be root of r squared, not r squared, basically we can write it out directly, we can write out r over here, so it will be 5 minus 2 under root 3, and this will be the final answer. B part, find the exact perimeter of the shaded region. For perimeter we can write arc length AB. If I'll show you the drawing, basically this is the diagram. So arc length AB plus BC plus AC. So these are the three parts. So AB arc we will be taking, and arc we know AB arc or any arc is equal to basically r theta. So theta in this case is pi by 6. So our perimeter will be equal to r theta plus BC, which we found, which is r under root 5 minus 2 under root 3, and plus AC is already r. So now we can write P is equal to r theta pi by 6r plus r under root 5 minus 2 under root 3 and plus r. So this will be our final answer for this part. Part C, find the exact value of the shaded region. So for exact value of the shaded region we have to find. Before going to C part, basically r theta is arc length, and r in this case is basically 2r, so we'll take 2r over pi by 6, and this value we will replace over here, so it will be 2 pi over 6 and r, so this will be cancelled. We can write this as an answer, or we can write pi over 3 r plus r under root of 5 minus 2 under root 3 over r. Our answer can be this one or this one, both are basically correct. Now we can move to part C, which is find the exact area of the shaded region. So shaded region we have to identify. This is basically ACB is the shaded region for which we have to find the area. So for that one we will check the area of this whole segment minus area of this triangle. That will give us the shaded area for this part. So we can write equation for shaded region. So shaded area is equal to area of the sector basically, or a segment basically, area of segment or sector, and minus area of triangle, Now area of in radian mode, this will be basically 1 by 2 r square theta, and this will be half AB sine C, half AB sine C means sine theta. So this will be equal to half AB sine theta. So this will be r will be 2r, because the radius is 2r square. So theta minus 1 by 2 into A is r and B other side is 2r into sine of pi by 6, which is value of theta. Now if we, this is also basically we can replace this as pi by 6. Now if we can simplify, this will be 1 by 2 and 4r squared into pi by 6, this one, and minus this will be cancelled. So r squared and sine of basically sine of 1 pi by 6, basically pi over 6, and this will be equal to 1 by 2. So we can write here 1 by 2. So r square, we can cancel this with this and this one with this. So pi by 3 r squared minus this will be r square over 2, and we can take r square common. So inside will be pi by 3 minus 1 by 2, and this will be our final answer for this. Question number 8. Diagram is provided. The diagram shows part of the curve. This one, the point, this and this lie on the curve. One is this point, second is this one. The shaded region is bounded by the curve and the line. Y is equal to 2 and X is equal to 1. Find the volume generated when the shaded region is rotated through 360 degree about Y axis. So to calculate this volume, basically we can find the volume of this whole portion, this one, and up to this one rotated about y-axis, and this rectangle, basically this rectangle, we will first find the whole volume rotated about y-axis, and then we will be subtracting from that volume, we will be subtracting the volume of this rectangle. And first we will find the whole volume, which is we have equation y is equal to 6 over x, and this implies x is equal to 6 over y, and we know integral of this one, basically rotated through y-axis will be from 2 to 6 pi and x square dx. This is how we are rotating. Now this will be pi into integral of this one will be 36 over y square. Basically we will be taking square of this whole, so it will be 36, basically x square value we have replaced over here, and before we will put the integral, and then we will be integrating this. So it will be integral from 2 to 6 dx. Now we will be integrating this, so 36 as it is, and we can take pi also, and it will be y minus 2 will be y raised to basically this will be y as it is, so we can write minus 36 over y, basically it will be if we properly integrate, this will be minus 1 over y, basically this one, from 2 to 6. So now we can basically replace the upper value, so it will be 36 pi we can keep inside, and inside we can write 36 minus 36 over 6, and the second will be minus into minus 36 over 2, and this one will be equal to pi, and into this will be minus 6. Basically I'll move the page a little above so that you can see. This will be minus 6 and this will be plus 18, which is equal to 11, basically 12 pi. So answer will be 12 pi, and this 12 pi is not the final answer. This is basically the volume including this shaded part, or this rectangle also. So to find the volume of this shaded part rotated about y-axis, we will be excluding this volume of the rectangle from this volume. So for this rectangle, basically for this rectangle we can take integral x dx. X value is 1, so we can take 1 x square, basically x square dx. So x, we can write x is equal to 1, so that's why we have taken 1 squared dx, and it will be 2 to 6 y also, because we are rotating this one. So this will be equal to pi, and we can replace the values 6 and minus 2, so this will be equal to 4 pi. So 4 pi is volume for this rectangle. So shaded region, we can write the volume generated. So volume shaded region will be equal to 12 pi minus 4 pi, which is equal to 8 pi. This will be our final answer for this question. Hopefully you understood this. B part, the tangent to the curve at point x is parallel to the line, this one. Show that x lies on the line y is equal to 2x. The curve we know is y is equal to 6 over x. Basically it is given in the main question, 6 over x. This is the curve, and they are saying that the tangent to the curve, so tangent to the curve will be dy over dx, which is equal to minus 6, basically minus 6 over x square, or we can write x raised by minus 2. This will be the tangent, and the equation is provided over here. So gradient of this equation will be, this line will be how much? This will be y plus 2x is equal to 0. So this implies y is equal to minus 2x. So gradient is basically minus 2. So m value we can write minus 2. So this is minus 6 over x square is equal to minus 2. This is basically provided the question. So we can write it as x square will be equal to minus 6 over minus 2. So this will be cancelled and this will be 3. So x is equal to basically under root 3. This will be the value. Now this is x value, so we'll replace in this one and we'll get y value. This implies y is equal to 6 over under root 3, and this one we can rationalize basically under root 3 and under root 3. So this will be equal to this will be 6 under root 3 over 3, and this 3 2s are 6, so 2 under root 3 will be our y value. So basically so this implies y is equal to 2x. So they are multiple of each other, so we can say that x lies, we can move page a little above, on the line y is equal to 2x. This is done. Question number 9. Function f and g. Function f and g are such that f of x is equal to this one. This is the range. G of x is equal to this one with the range. State the range of f and g. So first we can write the range of f of x. So f of basically we can write pi by 2. So it will be pi by 2 will be pi by 4 in this case. So it will be pi by 4. Pi by 4 basically writing. So it will be pi by 4. F of pi by 4 we can calculate. This will be 2 minus 3 sine pi by 4. If we calculate this, this will be basically equal to minus 1. If we calculate, this will be equal to minus 1. And f of 3 pi by 4 also we can check, that will be 2 minus 3 sine of 3 pi by 4, basically 2 into 3 pi by 4. And if we calculate this, this will be equal to 5. So the range for f of x will be basically range of f. State the range of f. So range of f will be, we can write here, range of f will be minus 1 to 5. This will be the range for this one. And now we can find the range for g as well. So g of, basically for g of 5 we will be checking, and that will be equal to minus 2 into 5. So it will be basically minus 10. And g of minus 1 also we can calculate, and g of minus 1 will be 2. If we replace here minus 1, so it will be 2. So it is 2. So range of g of x will be equal to, range of g of x is minus 10 to 2. So we can write this as final answer. Now we'll have to sketch this diagram. Basically the graph of y is equal to g of x we have to sketch. This is already provided, f of x is provided. So we know that range of f of x is from minus 1 to 5. So f of x is this one. So minus 1 is basically this one, minus 1, and 5 will be the maximum level of this. So this will, we can take it as 5. And this one for g of x, it is minus 10 to 2. So this value will be basically, we can take this as 2, and minus 10 we can take over here. Basically this value will be minus 10, and from here we can take points, for example. So it will be starting from here. So from 1 point we can take this one. It will be passing this one and going up to 2. So we can take this one because it has to pass through this. So we can take this one over here. It's rough, but I'm just to draw it properly, I'm just taking the point. So it's passing through this point, and it will be having minus 10 at this level. So it will be around this point. And now we have to sketch this graph. Basically from here we'll have to sketch like this one. So if we try to sketch this roughly like this one, and hopefully we'll be able to draw like this one. So it will be going back from here, and it will be moving up like this one. So this is how we have drawn this one. This will be our sketch, hopefully. So this will be the diagram. Now they are saying the function h is such that h of x is equal to this one, g of x plus pi, and minus pi to 0. Describe fully a sequence of transformation that maps the curve y is equal to f of x and y is equal to h of x. For this one, we can compare basically these two graphs, and we will notice three things. One is like it is basically reflection about x-axis, reflection in the line. For example, x-axis, so we'll write reflection in x-axis. So this will be the first point which we'll be writing, and it is also stretched by, see, this is also stretched, so stretched along y-axis, y direction. So stretch by factor, basically by factor 2, by factor 2 in y direction, and the third thing is that translation by minus pi. So it is also moved, translation by minus pi in x direction, So this will be the answer for our C part. Question number 10. The equation of the curve is provided. This one we have to find the first and second order derivative of this one. So for first order derivative, dy over dx, derivative of 54x will be 54 minus, or we can write first, then 2x minus 7 raised per 3 minus 1 will be 2 into derivative of 2x will be 2. So this one, and this will be 54 minus 2 into 3 will be 6 into 2x minus 7 squared. This will be first order derivative, then d2y over dx square. We can, constant derivative will be 0, so minus 6 into 2 into 2x minus 7 raised to power 1, and into derivative of 2x will be 2. So this will be 6 into 2, 12, 12 into 2 will be 24, so minus 24 into 2x minus 7. This will be the answer for derivative and second order derivative. Find the coordinates of each of the stationary points of the curve. So for stationary point, basically we will be putting dy by dx is equal to 0. It means 54 minus 3 into 2x minus 7 square, not 3, 6 basically, this one 6 is equal to 0, and this one we can factorize, and for this one, otherwise what we can do, we can open this bracket, or we can write factors basically. So if we simplify this, this will be minus this one 6 into 4x squared minus 49, and minus basically, otherwise what we can do, we can shift. Basically it will be a little difficult if we will be opening the square and then factorizing. So what we will do, we will shift this one to the other side. So it will be 6 into 2x minus 7 square is equal to 54, and divided by 6. So divided by 6, and this will be 9. So this will be 2x minus 7 will be equal to, basically square will be equal to 9, and now we can take root. So 2x minus 7 is equal to plus minus 9 we can write, and then we can find this one as, basically we can shift this 2x is equal to 7 and plus minus 9, so it will be x is equal to 7 plus minus 9 over 2. So x1 will be what? X1 we can write x1 is equal to 7 plus 9 will be 16, so 16 divided by 2 will be 8, and x2 will be equal to minus 2, so minus 1. These are the points. Basically we have done small mistake. This 9 root we have to take here, so it will not be plus minus 9, it will be plus minus 3 over here. So these values will change, so sorry for that, we will be taking plus minus 3, so it will be plus minus 3, so it can be this one. So this implies x will be equal to 10 by 2 5, and x is equal to 4 by 2, so it will be 2. So these will be the two values. Now we can replace these two values. When x is equal to 5, x is equal to 5, this implies y will be equal to, if we replace in y, basically this one, we can replace in this one or over here. Basically this is the derivative, so we'll have to replace over here. So if we replace in this, so it will be 54 into 5 minus 2 into 5 minus 7 cube. So if we replace in this one, we will get y is equal to 243, and if we replace x is equal to 2, so this y will be resulting to 54 into 2 minus 2 into 2 minus 7 whole cube, and this will be resulting to 135. So our point will be, x value will be 5 and y value will be 243, and the second point will be 2 and 135. So this will be the point and this will be the second point. Hopefully you understood this. Then C part, determine the nature of each of the stationary points. Basically we have to find the nature. So if we check d2y over dx square at x is equal to 5, so this will be equal to, second order derivative is this one. So in this one we will replace x is equal to 5, so we'll get minus 24 into 2 into 5 minus 7. So this will be equal to minus 24 into 10 minus 7 will be 3. So this will be basically minus 72. So this is negative, so it will be maximum point. So this will be basically the maximum point when x is equal to 5. So when x is equal to 2, this second order derivative d2y over dx square will be equal to minus 24. This will be at 2, at x is equal to 2. So minus 24 into 2, basically into 2 minus 7. So this will be equal to this one we can write equal to, basically this will be positive sign, it will be 22, and this is basically minimum point. So x is equal to 2 will be minimum point, coordinate of the minimum point. So this is how we can identify this. Question number 11. The equation of a circle with center C is this one. This is basically equation of center. Find the radius of the circle and coordinates of C. We know that general equation of circle is basically x square plus y square plus 2ax plus 2by plus c is equal to 0, basically this one. And we can compare this equation with this one. So 2a is equal to minus 8, and this implies a is equal to minus 4, and we can also compare 2b is equal to 4, so b is equal to 2. And we know in case of circle x minus a square plus y minus b squared is equal to r squared. So this will be basically, if we check this one, so if we want to write the center will be 4 and minus 2, because we'll be taking here, if we check from here, this is minus a square, so this should be sign will be changed accordingly. Hopefully you got this. Then the radius is basically this one, r squared, so in this case this will be equal to 5. So radius will be 5 and the point center will be this one. The point P1, 2 lies on the circle. B part show that the equation of the tangent to the circle P is this one. So equation of the tangent we have to show. B part, we will be finding gradient. Basically we have to draw a circle. So simple circle I'll just quickly draw. So this is basically the circle, and this one we can take as tangent. So this is the center point, and the coordinates of center are 4 and minus 2, and this is basically the radius r, and this point is 1 and 2. This is also given. This is I'll move the page basically upward. So this one. So this is the circle drawn, center, and the point P is this one. Now we can find the gradient of this r. So m of this r radius will be equal to y2 minus y1. So 2 minus 2 over x2 minus x1. So 1 minus 4. This will be equal to minus 4 by 3. So now the gradient of tangent, this is basically the tangent. So gradient of the tangent t will be equal to reciprocal and change sign, so it will be 3 by 4. And now we can find the equation of line using this tangent and this point. So y minus y1 is equal to m into x minus x1. So m is 3 by 4, y minus y1 will be 2, and x minus x1 will be 1. So here, so we can multiply. This will be 3 by 4x minus 3 by 4, and this will be plus 2 y. So this one we can simplify. 3 by minus 3 by 4 and plus 2 will be equal to 5 by 4. So we can write 3 by 4x plus 5 by 4, and this is equal to y. So our equation 4 we can shift to this side. So 4y is equal to 3x plus 5, which is the same equation. So this is done. Now C part. The point Q also lies on the circle, and PQ is parallel to x-axis. Find the coordinates, write down the coordinates of this Q. So for this part, basically more understanding is required as compared to the solution. So what we can do, we can draw a circle like this. So for your better understanding, I'm drawing this circle, and they're saying that the point Q lies on the circle at PQ, and PQ is parallel to x-axis. So we can take parallel to x-axis like this one. So this is parallel to x-axis. This is point P, this is point Q, and this is basically the center. So now the coordinates of P we already know, these are 1 and 2, and coordinates of center are 4 and -1, so we have to find the coordinates of Q. So if we directly go above this point, will be this one, and from here to this point the change in X is what? Starting from 1 to 4, so this is 3 units. Basically X value is changing by 3 units. So this is radius in card, so this will be 3 and this will be same 3 units. So 3 plus 3, 6 units will be added in X coordinate, so it will be having 7 as its X coordinate. Now we will be checking for Y coordinate. So see, this is parallel to x-axis. It means that there is no change in y coordinate. So whatever y coordinate this point is having, this will be having same y coordinate. So its coordinates will be 7 and 2. So we can write Q will be 7 and 2. This will be our answer. And because this is like 2-mark question, so we'll have to write that the reasoning also. We will write Q has Q has the same coordinates as y coordinates. We can write y coordinates as P, this one. And the second thing which we can write is Q is as far to right of C as P. So this means X will be equal to this already 1 unit plus this 3 unit and plus this 3 units. So this will be equal to 7. This is what we have done, and finally this is our answer. Q is 7 and 2. This is basically the point. The tangents to the circle at P and Q meet at T. Find the coordinates of T. So we can draw the same circle. Basically I'll draw a circle over here. So this is the circle. We will draw the tangents also. Now we have points. Basically we have this is basically the what do you call the center. Now we can draw the tangent, like for example over here we can first draw the radius, this radius, and we can draw another radius, like for example this one, and this is point P, this is point Q. And tangents also we can draw tangent, we can draw like this one. So it should touch the line at single point like this one, and the second side will be touching this. So this will be basically the tangents. So now what we can do, this is center O and having coordinates 4 and -2, and P coordinates we know this is 1 and 2, and for Q we found 7 and 2. These are the coordinates which we already have found. Now these are tangents, so this is 90-degree angles. Now what we can do, we can find the gradient of this gradient of radius OP. So M of OP will be equal to y2 minus y1. So we can take it as y2. So 2 minus minus 2 over x2 minus x1. So 1 minus 4. So this will be equal to minus 4 over 3. Basically this denominator will be minus, so we have written minus 4 over 3. So this will be basically this one gradient of this also we can find. Basically this is this point, if you are taking this point as t, so pt will be the tangent, so slope of pt will be equal to reciprocal of this and change sign, so 3/4 will be gradient of this one. And now we can use the point, and this point we can use, and the gradient we can use to write the equation of pt. So equation of pt will be equal to, like for example, y minus y1, equation of line and point slope form we will be using. So y minus y1 is equal to m into x minus x1. So this will be the m value which will be replacing 3/4, and x minus x value will be 2. X value will be 1. So this will be x value, and y minus y2 will be 2. So we can simplify. This will be 3/4x minus this will be 3/4, and plus this will be 2, and this will be basically we can write it as y is equal to 3/4x, and we can simplify this minus 3/4, and plus 2 will be equal to 5/4, so plus 5/4, and this will be basically the equation of tangent, or 4y is equal to 3x plus 5. This will be our equation for pt. Now we can find the gradient of OQ. So m of OQ will be equal to y2 minus y1, so 2 minus 2 divided by x2 minus x1, so 4. This will be equal to 4/3. So this will be basically the gradient, and the gradient of qt will be equal to reciprocal and change sign, so it will be minus 3/4, and the point we can take this and equation of line and point slope form, y minus y1, which is 2, and this will be equal to gradient, which is minus 3/4 into x minus x1, which is 7. So we can multiply. This will be minus 3/4x, and plus this will be 21/4, and this one plus 2 on this side, and this will be equal to y. And the final equation which we can write after simplification, 21/4 plus 2 will be equal to 29/4. So we can write y is equal to minus 3/4x plus 29/4, or we can write 4y is equal to minus 3x plus 29. This will be the final equation. And now for they are saying that find the value of coordinates of t. Now coordinates of t, we know that t is lying on pt as well as qt, so we can equate these two equations. Which two equations I will show you? One equation is this one, which is for pt, and the second equation for qt, which is this one. I have boxed these two equations. Both are equal to 4y, so we can equalize this on next page. So this will be 3x plus 5 is equal to minus 3x plus 29. So we can find the x value. This will be shifted to this side, so 3x plus 3x is equal to 29 minus 5, so this will be 6x is equal to 24, so x is equal to 4. So x coordinate will be 4, so this will be having 4 as x coordinate. Now we can find y coordinate. For y coordinate we can write, when x is equal to 4, y will be equal to what? 3/4 into 4 plus 5/4. This will be equation, and we can write as 3 plus 5, which is equal to, basically this will be 3 plus 5/4. So 3 plus 5 by 4 will be 3 plus 5 over 4 will be equal to 17 by 4. So this is equal to 17 by 4. So the point will be 4 and 17 by 4. This will be answer, and the coordinates here will be 17 by 4. Hopefully you understood each and everything. I have tried my maximum to explain. So I'll be waiting for your comments. Don't forget to subscribe Maths TV. Also recommend this channel to your friends and class fellows. Introduce this channel to your respected teachers also. Thank you very much for watching. Take care. Bye.